Hello my dear students, today we are in lecture number 17 of chapter 1. The same unit, electrostatics. Hopefully students, this will be our last lecture of chapter 1. I am B.S. Pandey. Student, in last class we have studied the applications of Gauss law. The first application we have studied the electric field due to conductor, that is the very large conductor, infinitely long conductor, that is a wire. If charge of lambda density, linear charge density uniformly distributed, then we have studied the electric field at any point at distance r as E is equals to, using the Gaussian surface, the cylindrical Gaussian surface we have made, it is the positive charge distributed throughout the conductor, that is the wire. E, it is lambda times 2 pi epsilon naught r. This was the formula that we have derived in last class for the conductor. Another formula we have derived that we will use in next chapter for capacitance also. For a thin sheet, if it is thin sheet, here I am drawing the two-dimensional diagram. If it is the sigma positive or negative, if it is plus sigma or minus sigma, if it is negatively charged plate, minus sigma, then due to this plate, electric field at any point, remember, electric field at any point, the minus charge sheet, it was E is sigma times 2 epsilon naught, and this negative will give you the direction. If you are finding electric field at this point, the electric field will be towards the plate. If you are finding electric field at this point, electric field will be towards the plate. Okay student, this is the direction of electric field. It will be obtained by the negative sign. Over here, this is the positively charged plate. Electric field will have the same magnitude, sigma by 2 epsilon naught. If you are finding electric field over here, then the electric field will be away from the plate since it is positively charged, and if you are finding electric field over here, the electric field will be away from the charge due to its positive nature. Students, in last class we have studied. Today we will start this lecture with the simple numerical. Okay student, the very simple numerical. The same system you will use and it will be considered as a capacitor. Okay, this is the plus sigma and minus sigma of the plate area, whatever may be. Okay, we'll discuss in detail later on. You have to find electric field at this point in between the plates. What will be the electric field? Students, try to find out the electric field in between the plates. You will find electric field, say this point as A. Okay, so the EA will be, first of all you have to find the direction of electric field due to the individual plates, either plate 1 and 2. Okay student, due to the plate 1 positive charge, as we have studied over here, the electric field will be away in this way. Okay, this is due to 1, and due to second plate the electric field will be towards, that is another electric field will be in the same direction. So you will have the two electric field and in the same direction, since the magnitude of the surface charge density are same, so the electric field magnitude will be same, and you will write here as sigma by 2 epsilon naught plus sigma by 2 epsilon naught, and you will have the sigma by epsilon naught. This is the net electric field inside, that is at point A inside the plate. If the same question I'll give you to solve, what will be the answer if you have to find the electric field at point B and electric field at point C. This is your next example, students. Try to solve, and I'm giving you the result. What will be the answer? You have to find the electric field at point B and C. Okay, so the two charged plate with equal and opposite charge density you are having, and you have to find the electric field outside the plates. Here at B, due to positive, the field will be away, due to negative, field will be towards. And if it is E1 and it is E2, here E1 equals E2, no doubt, and the magnitude will be same, sigma by 2 epsilon naught. Since both have the same magnitude and opposite to each other, will be cancelled out. So the electric field at point B will be how much? 0. Now in same way, outside the plate, second plate, the electric field due to negative one will be towards the plate, and due to positive will be away from the plate and will be cancelled out. So again at C, the electric field will be 0. Here you must have to remember, students, electric field outside the plate having the same surface charge density must be 0, and this system is considered a capacitor that we'll have to study in the next chapter in detail. Net electric field will be 0 outside the plate, but there will be field inside the plate, and that will be the use, and this will be the sum of the field due to individual plate. Students, I hope you are getting this example. So this will be your class 1. Okay, here the two plates, the plus sigma and minus 3 sigma. Okay, student, try to solve this question. You have to find the electric field at point A, B and C. This is the point A, B and C. Okay, student, try to solve. This is the first classwork, and the second classwork you have to solve. Here the 3 plate I am assuming. Okay, 1, 2, 3 plates. Okay, directly I'm writing the surface charge density, either sigma, minus sigma and plus 2 sigma. Okay, you have to find electric field at A, B, C and D. A, B, C and D. Okay, this is the homework. This will be your assignment. Okay, homework. So try to solve this question. What will be the answer of this question, student? Okay, now I'm solving this question. Here at point A, due to positive, electric field will be in this direction. Due to this negative, electric field will be in this direction. So you can write here the electric field at A, it is due to this plate outward, if plate 1 and plate 2, so it is E1 and it is E2. So E2, it is in positive direction, and E1. Okay, student, so the EA, it is equals E2, it is how much? Sigma by 2 epsilon naught, and the sigma is nothing but the 3 sigma by 2 epsilon naught minus E1 due to this one, sigma by 2 epsilon naught, and the sigma is how much? Sigma only, so it is 2 epsilon naught. And the net electric field, since we have been tricking, this one is the positive, so I cap, and you can solve this one and you will get the answer. How much it is? 3 minus sigma, it is the 2 sigma by 2 epsilon naught. So the net electric field, it is sigma by epsilon naught. Answer. Okay, student, so in this way you can solve this work also, homework. Okay, student, now the next topic we are moving for electrostatic shielding. Okay, student, so the next topic we will study electrostatic shielding. Shielding, it means protection. So the first point, try to keep in your mind, student, if there is any solid conductor. Okay, topic we are studying over here, it is electrostatic shielding. Okay, So shielding, it means the protection, and electrostatic shielding, it means you are protecting something with or from electrostatic field or the electric field. Okay, student. So the first point, try to be remember, for any solid conductor, if this is solid conductor, okay, if this is solid conductor, charge always resides on the surface. Charge resides on the surface of conductor. Kindly make down your notes. If positive charge, it is distributed, this will be uniformly distributed over the surface of conductor. What will be the distribution? Actually, this is also the matter of study. There will be the certain points that we have to study on which it will depend. Okay, and the second point. So the first point, remember, for the solid conductor, charge always resides on the conductor. If this is the conductor and electricity we are flowing from the conductor, so the charge always resides over this conductor, students. Okay, now the next point, any cavity, cell or hollow conductor placed in electric field, this is the external electric field. Suppose E and a conductor is placed inside this field, it is the conductor. Okay, it is hollow. So the conductor, if any conductor is placed, must be, this is the direction of electric field. If this is the direction of electric field and this is conductor, it must have some charge. So here the positive charge we will represent at this face. In the conductor there will be electric field, and negative charge will come to this side. So here the electric field, the external electric field, it is in this direction, and a induced electric field will be there, like induced electric field, and this induced electric field will be equals for this conductor the applied field. It is E in equals to E, and both are in opposite direction. Since here it is the E in opposite direction, so the both will be cancelled out. Hence E net will be how much? 0. So remember, in presence or absence, in presence or absence of external field, remember E net will be how much? It is 0. So try to remember this point. E net must be 0 whether the field, external field, is present or absent. Now the third point about the conductor. We are facing here the concept of electrostatic shielding, student. Okay, now the next one. If this is the conductor, hollow conductor, that is the cavity, and if any charge is put inside conductor, okay, any extra charge put inside conductor, what will happen? Due to, according to Gauss law, what should be? E dot dA should be Q by epsilon naught, and we have studied E should be how much? 0. Okay, E net should be 0. If E net 0, it means Q in should be also 0. Now how this net electric field, net charge inside 0? Here we are having the charge q, but how this charge will be 0? So you have to draw a Gaussian surface inside, just inside the conductor. Just inside the conductor, it means you are on the surface. Remember, this Gaussian surface you have been drawn and you are on the conductor, remember. So within this Gaussian surface you have applied this law and you got that E0. It means the Q will be 0 on this within this Gaussian surface. You know that to apply the Gauss law you need a Gaussian surface. So here net charge should be 0, but here we are getting plus charge, positive Q. How this will be 0? So there will be an induced charge. Here Q will be induced, and how much this Q will induce, how much this charge will induce actually. So the induced charge will be the plus Q, and Q induced will be same amount of the charge inside the conductor but opposite in nature. Uniformly a charge will induced inside, that is the on inner face of the conductor, and it is minus Q, that is Q at inner face you are getting minus Q. Now if you will find, since the Gaussian surface is just out of this negative charge, that is the induced charge, you will get the plus minus Q, and plus Q will be how much? 0. But we have to study after this also. If this negative charge was not present over here, then from where this negative charge comes? Since this conductor is electrically neutral, if negative charge comes over the inner surface, of the conductor, then how this becomes charged? And if this negative charge comes and it should be neutral, it means there should be some charge of same amount. But where that charge gone? Actually that positive charge of same amount that has been induced inside the conductor is shifted at the outer surface. Remember, here plus Q, here minus Q, and plus Q is resides on the outer surface. And remember, this is not plus Q plus Q plus Q, but this total charge equals to the Q. It means this Q is uniformly distributed over the outer surface. In short, you can write for your notes, if you are getting properly what I'm telling you, that you have to write in your notes the same amount of charge will resides on the outer surface. What does it mean? If there is a conductor and I put plus 5 microcoulomb over here, then it will come out with the same amount, with the same nature outside the cavity, that is the hollow conductor. Remember the student. But actually the total representation of charge will be in this way. This is the plus 5 microcoulomb, this is the minus 5 microcoulomb, and this is the plus 5 microcoulomb. This is the entire representation of charge. Remember student. Now the next point, student, we will get some examples over this point also, but the next point, remember student, net charge and net field inside the conductor 0, it doesn't mean that there will be no electric field lines if charge is 0. What I'm telling, actually, this is conductor, okay, and this is plus Q. Of course there will be minus charge will induce at the inner surface of the conductor, and the plus charge will be outer surface. I hope you are getting my dear student. The positive charge. Here E in the net will be 0, no doubt. Q net will be 0, no doubt. But there will be electric field lines. How? From positive to negative, in this way. Positive to negative, and this field lines also depends upon, and for this positive charge the field lines will be outside, okay, and this way. And remember, all the field lines should be perpendicular to the surface of conductor. We have studied in detail, okay. And take an example to draw the field lines. And remember, the field lines, what will be the shape of the field lines totally depends on the position of charge, where it is placed. If this charge is placed near the surface, then near the surface the field lines will be denser. To represent the field lines is denser, the charge distribution will be a little bit different in compared to the other part which is at the large distance. The next, so the example, the simple example I'm giving you, my dear student, if this is a conductor, okay, here the -5 microcoulomb I have been placed, okay. You are having two surfaces, surface 1 or surface 2. Here the surface 1 is inner surface and 2 is outer surface, okay. You have to write the charge on inner surface, okay. So the Q1, or you can write the Q in, Q out. Q1, it is the Q in, and Q out, it is Q2. So the Q in will be how much? Q in with the inner surface, how much it is? Plus 5 microcoulomb. Very good. And the outer will be -5 microcoulomb. So this is the very simple concept, but very important. Now, student, another question I'm giving you, and you will find how to find the surface charge density, okay. How to find the surface charge density. So we are studying now the surface charge density. Surface charge density, the next topic. So the charge density, surface charge density, we often represent by the sigma, and it is the charge we have studied already per unit area, okay. This is the conductor, I'm sorry, this is a conductor of radius r, Here the charge, suppose at the center we have placed plus q, so you have to write the surface charge density at inner surface and outer surface of this conductor, my dear student, okay. Okay, this one. So the sigma in will be inside, how much charge will be there? Minus q divided by area. If it is radius r, then 4 pi r square, and sigma out, it will be plus q divided by 4 pi r square, okay. Now the next question, your classwork. Suppose this sphere, here plus 5 microcoulomb already present, and you have put inside the conductor at the center, it is minus 10 microcoulomb. Now what will be the final charge distribution and surface charge density, okay. So this is the answer. If you can solve, pause the video and try to solve this question. Here at the center minus 10 microcoulomb, so plus 10 microcoulomb will induced, and the minus 10 microcoulomb will come out, but already here 5 microcoulomb, and the charge has the additive nature, so the total charge, that is the sigma in, will be 10 microcoulomb, 10 power minus 6 at the radius, suppose it is r minus 6, divided by, with the positive nature, surface charge density, here divided by area 4 pi r square, and sigma out, it will be, how much total charge will be over here? It will be minus 5 microcoulomb. So minus 5 microcoulomb over same area pi r square. Okay student, so this is the answer. Now my dear students, one question from NCERT. Okay, this is a conductor having charge q. This is another conductor in which a cavity is present. This is cavity, and a plus q charge over here. Now student, what will happen if we will place this conductor inside the cavity? You have to represent the surface charge density, or you have to write the charge distribution, final charge distribution. That is the final charge distribution will be what? Okay, I hope you can solve this question. It's very easy. The final charge here inside the surface of cavity, the charge will be minus q, and outside it will be the q plus q if this is the solid conductor, okay, placed inside the cavity. I hope you can understand. Okay, now the next concept, student. So now my dear student, if we have placed a charge at not exactly on the center, but suppose the radius of this conductor is r, okay, and here plus q charge is represented, but at a distance r by 2, if we put a charge minus q, okay, then what will be here the condition I'm giving you? This is another example, student. Okay, the condition I'm giving you here, q is greater than, the magnitude of q is greater than the small q, and you have to represent or draw the electric field lines, and show the charge distribution. So the charge density, surface charge density. Okay student, so this is question. If you can solve this question, pause your video and try to solve, my dear student. Now the answer. Remember student, whatever may be the position of the charge, whether it is on the center or at certain distance, the distribution of charge is not going to be changed. But the field lines, as I told you, the field lines will be certainly changed. Here the center and the charge is minus q is placed over here. The total charge is the plus q, and minus q will be here. Remember, this will be positive. Why? The condition is there, q is greater than q, so the total charge, net charge, will be positive. You can draw the field lines also. If charge is here, then plus charge will be induced at the inner face, no doubt. Here the field lines will be denser, and I'm taking this, remember this is minus q, I'm taking this as a curve so that I can get the field lines perpendicular everywhere. This was the negative, I think, no? Yes, this was negative. The field lines will be from positive to negative, no? So this will be the direction of field lines. Outside the conductor, you can also draw the diagram. The field lines will be, since it is positive again, so the field lines will be outward. And where these are going, can any student tell me where these lines are going? Yes, anyone? Nice. It is going at infinity, so everywhere it is perpendicular and the field lines are straight. Okay, student, so these are the simple concept of electrostatic shielding and the concept of conductor. Okay, student, in next class we will study how to distribute the charge over the plates. Okay, student, so this is all about today lecture. Thank you, student.